So now we'll be moving on to stationary points. And there are three types of stationary points: a maximum, a minimum, and a point of inflection. And a maximum is concave up. No, sorry, not concave. Sorry, convex up. And it's when. So I should start off by saying a stationary point is when dy dx equals 0. For a maximum, the gradient goes from positive to 0 to negative. So the rate of change is decreasing. For a minimum, it'll look more like this. And here it goes from negative gradient to 0 to positive, so the gradient is increasing. And then at a point of inflection, it'll look something like this. And it's when you either go from positive to 0 to positive, or negative to 0 to negative. So how can we, and I should also say, you can have a global or a local, and a global or a local maxima or minimum or maximum. And so a global maximum is when it's a maximum point and it's the lowest point on the graph. Sorry, a global maximum is when it's a stationary point that's a maximum, but it's also the highest point on the graph. But a local is, say, like this, in a cubic function. It is a maximum point as in a stationary, but somewhere else on the graph it goes higher. And it's a similar thing for global and local minima. Like that. And then point of inflections are point of inflections. So really there are 5 types of stationary points. Now how can we if we're given stationary points, how can we determine the nature of them? So let's take the example x squared plus 9 over x, and we need to find stationary points and their nature. At stationary points, dy dx is 0, because if you were to draw a tangent, it would end up being a flat line, which will have gradient 0. So dy and dx is equal to, y is x squared plus 9 multiplied by x to the power of minus 1. So it's x plus 9x minus 1. So dy dx will equal 1 minus 9 x to the power of minus 2, which is 1 minus 9 over x squared. Now when will this be 0? Equals 9 over x squared, so x squared equals 9, x equals 3, or x equals minus 3. Now you take each of those, put them into the function. Like so. So you know that the points will be 3, 6 and minus 3, minus 6. But now how do we find their nature? How do we determine their nature? Now, if we think about this, we can just do gradient to one side and gradient to the other side to figure out, well, if it goes positive on the left, negative on the right, then that'll be a maximum. And if we go negative on the left and positive on the right, it'll be a minimum. And we want to try and go very close, because there's a risk you might have another turning point, especially with cubic functions. And obviously if it goes positive to positive and negative to negative, that's how you can detect if there's a point of inflection. But generally, if I'm doing a question like this, the first thing I do isn't that. That's a plan B. What I would normally do is I do the second derivative, d squared y over dx squared, or f double dash x. And so that would be equal to, well, the constant, 1, differentiates to 0, then minus 9x to the power of minus 2 gets you 18, x to the power of minus 3, so 18 over x cubed. Now I do my evaluation for each. 18 over 3 cubed. And so it's 18 over 27. And I don't really care about simplifying it that much. All I care that it's positive. Therefore, that will be a minimum. And the reason for that is because d squared y over dx squared is the rate of change of gradient. So, and because we're going from negative to 0 to positive, we're increasing the gradient. So the gradient is increasing, so the double derivative should be greater than 0. And conversely, the double derivative for a maximum should be less than 0. Which it is, it's negative 18 over 27, which is less than 0, therefore maximum. What I would say is minimum at 3,6, maximum at negative 3, negative 6. And if you want, you could clarify if it's local or global, but that doesn't really matter, I don't think. Now, if it was equal to 0, then that is inconclusive, and we must do a gradient check. And again, go very close to the stationary point to prevent a false positive or a false negative. And remember, chain rule still applies. You may have to use chain rule. I'll also note that points of inflection is not required content. And also note those shapes of stationary points that I drew at the start of the video, and how you can use information about stationary points to guide your sketches.